Hello, welcome to another video in Roy's desk. Sorry for not uploading any videos recently. I was stuck with some work. I could not make any videos in between. As I said in the last video, I'll be comparing the power output between these two boards. This is with UTC2050 and this is with LM1875. I have recently uploaded one YouTube shorts where I have soldered this board with the LM1875 in here. So first we'll do the sound test, then we'll move into testing with our dyno setup. So let me grab one YouTube safe music. I think you're able to understand the difference between the sound quality of these two chips. I feel this is far more superior in clarity. So without wasting any further more time, let us quickly move on to the testing part of it. I'll be first testing the LM1875, then I'll be testing the UTC2050. We'll test with 8 ohms and 4 ohm loads. So I've made all the connections in here and now it looks like a rat's nest, but I will go through the connections. So basically here is our function generator, which will be outputting sine wave of 1 kilohertz, and this is the same supply which I used earlier, 13013, rectified and filtered to close to 17 volts plus minus DC. This is our amplifier, the output from the function generator to the input of the amplifier, the output of the amplifier connected to this resistor network. Now I am having two 8 ohms 100 watt resistors and I've connected those in parallel, and I have a switch. So if I switch it on, I'll have 4 ohms because these are in parallel, and if I switch it off, I'll have 8 ohms. And I've connected the oscilloscope across the output of the function generator and also the output of the resistor network. So blue line is basically the output of the function generator, and yellow line will be the output of the amplified output of the amp. So I'll slowly increase the amplitude in the function generator and we'll see the point till clipping. So here, close to clipping. Okay, if I just move the blue line out of here, say it's close to 30 volts peak to peak, a little. Okay, now we are clipping. Yep, 30 volts peak to peak. So you'll note it down. So if you are wondering at what voltage I am driving the amp now, it is 33.5 volts DC, the total voltage, and basically 16.67 volts plus minus DC. So same setup again. Now I have switched on the 4 ohm load here. So now we will again check how much V peak to peak we get with 4 ohms, same supply voltage. So I'll slowly increase the amplitude till we get clipping in the yellow line, which is the output of the amplifier here. So we are getting to clipping now. Okay, it is 28 volts peak to peak. We'll note it down again. Now before moving on to testing the UTC2050 here. I am thinking I will also test it with 19019 winding. So earlier I was testing with 13013 winding. Now I also have 19019 winding in this transformer. So I've hooked up the 19019 winding. So we'll quickly check the voltage that we are getting now in the output. Yeah, 48.8 volts total, 24.5 volts, plus minus 24.5 volts basically. So we'll see where it clips in this case. So I'll slowly increase the amplitude again, and where do we see clipping now? Okay, now close to clipping. This is clipping basically, and a little bit more maybe. Yep, 42.8, close to 43 basically, 43 volts peak to peak. Now I'm not going to test 4 ohms with this 19019 setup because there is some current limit inbuilt in this IC of 3 amps. So if I hook a 4 ohm in this setup, it will current limit before clipping. So I'm not testing 4 ohm in 19019. So we'll move on to testing this UTC2050 now. I will directly come back with the results. The setup will be same. I'll be first testing with 13013 8 ohms, 4 ohms, and 19019 8 ohms. I will quickly come back with all the results and we'll compare both of this. Recorded the performance of both the chips in different conditions. So if you compare this two, and the result is very shocking, that the LM1875 at 16 volts, close to 17 volts plus minus DC, it gives peak to peak voltage of 30 volts and VRMS of 10.60 volts. Basically V peak to peak divided by 2 root 2 is VRMS of 10.60 volts. At 8 ohms it gives 14 watts. In the same place, same conditions, UTC2050 gives 14.43 watts. Next, if we move on at plus minus 16.7 volts, same voltage, only difference is we have hooked up 4 ohms in this case now. At 4 ohms it gives VRMS of 9.90 volts and we have 24.5 watts. But same case, same condition, UTC2050, it's giving 25.9 watts. So it's more 1.4 watts more than LM1875. And in the last case, plus minus 24.5 volts, 19019 transformer, the LM1875 was giving V peak to peak of 43 volts, which means VRMS of 15.20. At 8 ohms it was giving 28.8 watts, but UTC2050 under the same condition is giving 30.81 watts. So the UTC2050 is definitely performing better in this case. I cannot test the FFT response of these chips. I mean, there will be some differences in the FFT response, in the distortion response of these chips, but unfortunately I cannot test it. But if you just see the performance of the ICs, UTC2050 is clearly a winner here. But according to me, as per my ears, I feel LM1875 is having more clarity in sound than UTC2050. But performance wise, wattage wise, UTC2050 is definitely a clear winner here. So if you see everywhere, all the different voltages, UTC2050 has performed better. And I don't know why I feel the UTC2050, even with the small heat sink, it's not getting as hot as the LM1875, which is having comparatively a bigger heat sink. So I don't know, everything, all the circuit diagrams, everything I provided in my previous video, everything is same in both the chips. The circuit board is same, everywhere it's same, just the heat sink I have put different here to use this in my tweeter circuit now. So in next video I'll be making the high pass filter, high pass preamplifier basically, and I will design it and then I will test it with our oscilloscope. So that's it for this video. I'll see you in the next video with a new circuit, with a new testing video, and till then, bye. Please do like, share and subscribe.